Hamidi Younesi, and I'm glad to see you in this MUM in Armenia. My presentation is about the VPN and Tunnel concept with an IP and IP configuration between Cisco device and Mikrotik router ones. In this slide, you can see my information. I am a Mikrotik certified trainer. You can connect to me with the Skype account, Instagram, and you can see my email address and etc. My presentation topic is about the fundamentals of VPN technologies a little bit, and then a benefit of tunnels. After that, we speak about types of tunnels, and then we go to the IP in IP configuration scenario. There is an increasing demand nowadays to connect to the internal network from external networks like internet. The employees often need to connect to the internal networks to reach the resources, internal resources of your networks. For example, from home, from a hotel, airport, and etc. And any other places. For example, to talking with the soft phones on his or her laptops to any staffs of your company, and for example, send a print to a printer in your internal networks. So VPN is a helpful solution for me. VPN is standing for Virtual Private Networks, and a VPN transmits data by means of the tunneling. It means that a packet before it's transmitted, it is encapsulated with IP in an IP packet with the new header. This header provide the routing information to route the packet to into the shared network and internet. And after that, before the packet arriving to the endpoint of tunnel, decapsulated, and then go to the final destinations. When we need to configure a tunnel, we need the both ends of the tunnel needs to support the same protocol. For example, you can't set the IP in IP with GRE tunnel in both sides of the tunnel. You must use the same protocol. Tunneling protocol are working at layer 2 and layer 3 of OSI model. In this slide, you can see the benefits of tunnels. We speak about the benefits of tunnels. For example, the tunnel decreasing the cost. What it means? What does it mean? Imagine that your manager asking you about to connect a central office with the branch offices networks. What did you do with this task? If you need to communicate these two networks with, for example, dedicated fiber links, it's very expensive. So we can go to the solution like VPNs to connect these two networks resources. So the tunnel, you just need to buy an internet connection between for these two offices, and then lease an public IP address, a static address, and then you buy for example, to Mikrotik router OS and configuring the IP, configuring the tunnel or any other VPN solutions. So your staffs, your employees can simply connect to each other. For example, use shared folders from central offices. For example, you have Active Directory server in your service, your central offices, and the branch office can connect easily to central office. So tunnels and VPNs decreasing the cost for us. And the second benefit is scalability. Imagine that in the morning you go to your workplace, your office, and your manager asking you about connecting a new building networks to your central office. You just need, for example, run the VPN, for example, L2TP tunnel or a PPTP tunnel, and create the username and password for example, new 20 users in the new building, and then send it username and password, and create a network VPN connection for them. And then, if they have an internet connection, they can connect simply to your central office and use all of the resources to your network. So you can easily so the VPN simply scalable. The VPN provides confidentiality by encryption, and you can provide authentication with the tunnels and VPN, but by default the VPN and tunnels have not provided a strong authentication for you. You can add simple username and password and send it to your user, your client, and they can connect to your VPN server. So this is the challenge for the tunnels and VPNs to provide a security, provide a strong authentication. Data integrity. Data integrity means that nobody can inject bits into the packet that travels through the tunnels or VPNs. Anti-reply. Anti-reply is a method of attacking to your packet goes through the tunnels. You can prevent this attack by, for example, IPsec tunnel. For example, you can have an IP GRE tunnel and then combine it with the IPsec tunnel, for example, or any other VPN. You can combine them to IPsec tunnels. In this slide, you can see the two main types of tunnels. The first type is remote access tunnels, as known as VPN, Virtual Private Network, and the second type is site-to-site VPN. Let's see this simple remote access sample. Imagine that you have your staff needs to, for example, travel around the world with her or his laptop, his computer, and he or she need to connect to the internet, and then need to connect to your central office, and need to connect to your internal resources. So you can, for example, use the VPN, for example, PPTP tunnel, L2TP tunnel, and set the connection for him to connect to the resources. This is the site-to-site, for example, GRE tunnel. For example, you have two routers in two buildings in your city or in another city, or it's in another country. You need to just buy an internet connection and lease and public IP addresses, static addresses, and then you can configure the tunnel between these two sites. In this slide, we see many types of tunnels. For example, IP and IP tunnel and GRE tunnel working at layer 3 tunnel, layer 3 of OSI model. The IP use protocol port number 4 for IPv4 and 41 for IPv6. And the GRE use IP protocol number 47 for connecting two sites together. GRE stands for Generic Routing Encapsulation. And then we have an EOIP tunnel. It's Mikrotik proprietary and stands for Ethernet over IP. It's layer 2 tunnel working at layer 2 of OSI model and use IP protocol number 47, same as GRE tunnel. In other hand, we have L2TP and PPTP tunnel that works in layer 2 of OSI model. The L2TP needs a 1701 UDP port for. I write this port for any other use. For example, firewall filtering. You need to open this port to connect your VPN or tunnels, for example. PPTP use 1723 TCP port. The IP and IP tunnel is a simple tunnel that encapsulates one IP packet in another IP packet by means of tunneling between two routers. It adds outer IP headers, and after that you have inner IP header, and then you have IP payload. The GRE and the IP work as same as the GRE tunnel, but the difference between these two tunnels is the GRE have an outer IP header. After that, it have GRE header. Then it have inner IP header and IP payload. Let's start the IP and IP scenario between Cisco 1841 router and Mikrotik router OS. In this scenario, we have, for example, two public IP address, a static address for these two routers to connect, for example, to the internet, to the public network, and then we have two LAN networks with this range that you can see in my slide. The task is PCA with IP address 192.168.12 need to pinging PCB. After that, we create an for this I create an IP tunnel. The first step is configure an IP address in Mikrotik router OS. You can see the IP address configuration command. You need to set the IP address for being gateway for their local network. On, for example, Ethernet 1, and then you need to set the WAN address to connect to the public network, to the internet. In the Cisco router, you need to go to the configuration terminal mode, and then go under the interface that you need to set the IP address for your LAN and LAN and WAN address, as you can see in both sides of the slide. Then you need to add default route. Let me talk about this commands that you can see in this slide: IPNet inside and IPNet outside. This configuration needs to configure after setting the IP address and when you need to setting the source net configuration. The IPNet inside means that you can tell the router that which interface needs to be, for example, in a LAN network, and the IPNet outside is the WAN address interface. You need to add a default route, configure a default route. In the Mikrotik router OS, you can see this command: IP route add and destination address //0 with the gateway that reach to the ISPs and then go to the internet. In the Cisco router, you need to go to the configuration terminal, and then you can set these default route as the same as Mikrotik with a little bit different. Then you need to configure the source net for these two routers to direct your clients from your LAN network to the public networks. In the Mikrotik router OS, you need to go to the IP firewall and then go to the NAT menu, and you need to choose the chain source net, SRC net, as you can see here, and out interface that the client packets needs to direct to the internet, to the WAN. But in Cisco router, it's a little bit different. You need first you need to configure the access list for telling the router that which addresses need to be source netted and directed to the internet, and translating to the public address. Then for configure the source net, you need to set the IP net inside source list. You need to tell these access lists that you created before, and then you need to choose the WAN interface. For IP and IP configuration, you need to go to the interface menu in Vimbox and then go to IP tunnel. I put it in my slide. But it's very simple. You go to the IP tunnel in Mikrotik. You choose a name. It's not mandatory, but you can left it as default name. The important things is the local address. You choose the local address and remote address. The local address is your public IP address, and the remote address is your partner public IP address that you can pinging from the internet. Then in the right side of my slide, you can see the configuration on Cisco router tunnel configuration. You need to configure interface, first interface for tunnel, and the tunnel interface number, and then you can use the configure the IP address for the tunnel. I use for 172.16.1.1/30. Then you need to tell the router that which IP address is your public IP address with tunnel source address, tunnel source command, and then you can configure the partner public address. And then in Cisco, you need to configure the tunnel mode. As you can see, I choose tunnel mode in IP in IP. After that, we need to set an IP address on other side of the tunnel on Mikrotik router OS. Here we have 172.16.1.2/30. As you can see in my slide. Now it's time to verifying the connections. We must pinging PC A from PC B or reverse. For example, a ping from PCB to PCA. You can see the ping is correct. The pinging is correct, and you have ping. And then, for example, you can trace the route result from PCB to PCA. See, in this slide, we show with red typing. Your packet must go through the tunnel, not go through the public network, for example, internet. Okay, and look at when you're pinging, when you're tracing, when you're, for example, need the other resources of the internal resources of the other side of the tunnel. You can check the tunnel traffic in IP tunnel interface, and then go to the traffic tab. If your configuration is correct, you must see this traffic into your tunnels. If you have any question about the IP and IP tunnels or tunnels and VPNs between Mikrotik and any devices, I stay out there in the lobby, and you can ask me any question. Thank you very much.